solve by completing the square. So we have x squared plus 4x plus 5 is equal to 0. Now when we complete the square with the first two terms of a perfect square trinomial, of what's going to be a perfect square trinomial. So the first thing I want to do is to move that 5 over to the right by subtracting a 5 from each side of the equation. So what we have looks like x squared plus 4x is equal to negative 5. So now we want to complete the square on the left. So let's recall that to complete the square, what we do is we take the coefficient of x, we divide it by 2, and then we square the result, and that is going to be the constant term in our perfect square trinomial. So, keeping that in mind, the coefficient of x is positive 4. So we want to take 4, divide that by 2, and then square the result. So we end up getting 2 squared, which is 4. So now on the left, we want to add a 4. But remember, we're looking at an equation here. So whatever you do to the left side of the equation, you have to do to the right side of the equation to make everything even, sort of. This is sort of balancing out the equation, because if you only add a 4 to one side, then you're technically going to be solving something different. So then on the right side, we want to introduce another 4. So there are 2 4's introduced on either side. So now on the left, this becomes the square of a binomial. In particular, this becomes x plus 2 squared. Right? This is x plus 2 times x plus 2. And then on the right side, we just have simply negative 1. So then, we solve for x, right? So the first thing we do is to take the square root of both sides. And on the left, the square root and the squared is going to cancel out, and we're just going to be left with x plus 2. And on the right, we get plus or minus the square root of negative 1, which is also known as I, but let's leave it as the square root of negative 1 for now. And then finally, in our last step for solving for x, we subtract a 2 from each side. So x is equal to minus 2 plus or minus the square root of negative 1. Or, if you want to use complex variables notation, this is x is equal to minus 2 plus or minus I. Since for complex variables we have that I is equal exactly to the square root of negative 1. So the solutions are x is minus 2 plus I, and x is minus 2, x is equal to minus 2 minus I. And so that's our final results.